Delicious. Flavorful. Crunchy. Simply irresistible.
You ate all the Lays?
Sorry.
Ha! We got more!
Lay's. Simply irresistible.
One bag, one crunch, and suddenly you're deep into a factory you never knew existed. Tens of thousands of potatoes, laser scanners, rivers of oil, all to deliver that perfect chip. Ever wondered how that bag made it into your hand? Let's go behind the scenes. Get comfortable, the journey begins now. We grab that crispy snack without a second thought. But the story behind it spans farms, science labs, massive machinery, and cutting-edge logistics. Today, we journey inside one of Europe's most advanced chip factories, the kind that makes millions of bags a day. You'll see how a humble potato becomes a bag of snackable gold. And I promise, you'll never look at your next chip the same way. And stick around, we'll reveal the tiny secret that keeps chips from breaking during shipping. It's not what you think. It all begins in the fields. Special potato varieties are grown for chip making higher in dry matter, lower in reducing sugars to avoid dark spots when fried. Farmers use deep reach harvesters that lift entire plants, soil and all. A vibrating conveyor shakes off dirt, while up to 4,000 potatoes per minute can pass through in peak harvest. Trucks drive alongside the harvester to maintain flow, no downtime. Because time is money and quality decays. Once loaded, the potatoes head to a massive storage hub, essentially a potato hotel. Crates stacked high, climate-controlled. Why? Because if potatoes sit at wrong temperature divided by humidity, their starch converts to sugar and you get dark, uneven chips. But selecting the right potato is only half the battle. Next, the first line of real testing. When a truck arrives at the factory gate, it isn't simply unloaded and forgotten. Samples are pulled. Some manufacturers even punch holes in select tubers to track their journey and test internal quality. Trucks that exceed defect limits can be rejected entirely. Every spud matters. Then the load is discharged. Sometimes platforms lift trucks and tilt them to pour potatoes like a waterfall onto conveyors. Millions of potatoes drop at once. Then they roll into the cleaning zone. Next, dirt removal with million-dollar machines you won't believe. First stop, cleaning. Potatoes pass through water jets, brushes, and swirl tanks to remove soil, rocks, debris. Even a single speck of stone can crack slicing blades or ruin downstream equipment. Some rinse lines can handle up to 6 million potatoes a day. After mechanical cleaning, workers impersonate gold miners, standing at conveyors, spotting green patches, soft spots, deformities. It's the human layer of quality, and the machines will dock you big time if you slide through with a bad spud. We'll see how soon. Next, the peeled process. Potatoes tumble in large drums with abrasive interior and water jets blasting to remove skins. After peeling, a high-speed camera system assesses each tuber in milliseconds. Any sign of rot, bruise, or discoloration triggers a pneumatic puff that ejects it from the line. Imagine tiny robotic arms flicking out bad potatoes faster than you can blink. Then the size sorting stage. Only potatoes within size limits advance. Oversized ones are cut or diverted. Uniform size ensures the next steps, slicing, frying, are consistent. Because uneven size equals uneven slice equals broken crunch. Next, the slice that defines the chip. The slicing stage is where science meets crunch. Using drum slicers with centrifugal force, potatoes are propelled through razor-sharp blades and turned into paper-thin slices about 0.06 inches thick, is approximately equal to 1.5 millimeters. If slices are too thick, chewy, or heavy, too thin, curl, fold, break. The industry knows this. Straight blades produce classic chips. Serrated blades produce rippled chips with extra surface area for flavor. Picture a ripple like a wave. It holds more seasoning and creates extra crunch. That's no accident. Quality technicians continuously monitor thickness using gauges and online sensors. The slightest variation impacts texture, frying time, and final bag appearance. But slicing is just the beginning. Next, we prep the slice for the fiery transformation. After slicing, the raw chip is still unstable. Surface starch sticks like glue. If left, it causes slices to stick during frying or brown too fast. So they go through a starch removal zone, soaking drums, water jets, and multiple rinse cycles. Some operations remove up to 70–80% of surface starch. Then, slices pass through drying hot air or vibration conveyors, remove residual moisture before frying. This step is critical because water left behind creates steam bursts in the fryer and can cause breakage or inconsistency. And now, we arrive at the furnace, the fryer, where the real transformation happens. Frying is where the potato really becomes a chip. Continuous fryers up to 12 meters long keep a stable oil bath. The temperature hovers around 175 degrees Celsius, is approximately equal to 350 degrees Fahrenheit. Slices remain immersed for roughly 2–4 minutes depending on moisture and starch content. Operators use the float test. The moment a slice floats in oil signals structural change. Interior water is gone. Oil fills the vacated space. You get crisp. Composition of oil matters. High oleic sunflower oil is now preferred to reduce saturated fat levels. Many factories use a blend, fresh oil plus used oil. Why? Too fresh. Chips absorb too much and become greasy. Too used, color darkens. Flavor suffers. Balance is everything. You'll see chips bubbling, rising, goldening, and then gently lifted out. Vibrating conveyors move them forward because belts would crack them. And even after frying, the story of each chip isn't over. There's a laser eye waiting down the line. Hot chips arriving from fryer still have to pass ultimate quality control, optical sorters. Machines scan hundreds of slices per second, looking for brown spots, folded chips, cracks, breakage. If detected, whoosh, a jet of air blasts it out into a reject tray. This is how you open a bag and almost always find golden intact chips, not burnt bits or chips gone rogue. And in some factories, metal detectors and X-ray systems check for foreign matter, tiny metal fragments, rocks, or other hazards. Chips freshly fried, still hot, and slightly oily, ideal for seasoning. They roll in a flavor drum. Measure the seasoning, tumble the chips, coat both sides. Flavor engineers design blends. Herbs, spices, smoke, tangs. Over 200 global flavors exist for major snack producers. Heat helps powders adhere. The process must guarantee uniform coverage. Machines sample chips and measure coverage, moisture, flavor intensity. Too little, bland, too much, overpowering, or oily. Imagine a chip being showered in flavor dust while spinning like a mini carousel. Once seasoned, it's nearly showtime for the chip, but first, precision weights and that mysterious air cushion. Chips head into packaging territory. Multi-head weighers, 120+ heads, drop micro portions of chips into bags, from snack packs to party size. The algorithm picks hoppers, combinations to hit exact weight. Then the bag is filled, flushed with nitrogen, sealed. That headspace you see? Not empty. It's the air cushion that protects chips from crushing. Nitrogen replaces oxygen to slow oxidation and staling. The bags are collated, boxed, stacked on pallets, wrapped and shipped out within hours. Want to know why they wrap pallets in plastic? Because a broken chip equals lost product value. But there's more. Sustainability is joining the party. Snack manufacturing isn't just about crunch and flavor anymore. Sustainability is front row. For example, potato skins, peels, and rejects are used as animal feed or biogas. Water from washing lines is recycled and filtered. Oil is reused or processed for energy recovery. Innovation labs experiment with reduced fat chips, new textures, alternative frying technologies, or air frying. Variety matters. Variety of flavors, formats globally, as we saw earlier. So the next time you reach for a bag, you're not just grabbing a snack, you're grabbing the product of an entire ecosystem of food science, engineering, and sustainability. So let's recap. Potato from field storage cleaning, peeling and sizing, slicing, de-starch, rinse, frying, optical inspection, seasoning, weighing and packaging, shipping. Every step meticulously engineered. Next time you hold a chip, remember, you're holding a tiny bit of engineered perfection. If you enjoyed this deep dive, give it a thumbs up, subscribe, and ring that bell so you won't miss upcoming episodes. Have a snack, gadget, or product you've always wondered about? Leave a comment, and I'll see if we can open the here and now factory doors for you. And now, I'm going to treat myself to a bag. Can you stop at just one chip? I'm the factory line, and this is how Lay's chips are made.